Now let's replay that script. So I open up the robot model window. Here we can see if I click render in real time, we can take a look and use the A and D keys. We can look at what the accelerometers are telling us about this robot. Although currently it's only a torso and legs and feet, it draws in the rest. So we can kind of see it's leaning forward a little ways. It's not good to keep this running because it does use up a lot of CPU. And it can cause problems. So we're just going to load log, this last log. It's always the last one since it's got the file name is based on the date and time, the timestamp when it was made. This was our script, right leg lift 3. I'm going to go ahead and click OK. So now if we want to just step through this stuff, we press, let's see, F for forward frame. We can see, okay, script file name. We can see the log entries. Here it has an Excel torso. Giving us the accelerometer and gyroscope data for the torso accelerometers, and that includes the waist. The next one is the left leg accelerometer, if I get my neurons, giving us that accelerometer and gyroscope information for the left leg, which then is reflected on the model. The right leg comes next. You can see 7 milliseconds. So you want to go backwards. B will take you backwards. The beginning, 0 milliseconds is the beginning. We get the first 5 milliseconds into this script. We got a torso sample. Then the left leg came in at 6. The right leg came in at 7. So the next thing that happened was the touch sensor for the left leg. Although there are no touch sensors currently on this, it does send that information. The touch sensors for the right leg are sent. Okay, so it says, okay, I'm starting stage 1. So that tells us that. It tells us, okay, this angle, lower left leg is out of range. We want it to be -5. It's currently 3. So it's tilting left. The reason it's out of range is because the user is saying, make this Z angle on the lower left leg, make that -5. So it's going to try to strive for that. It's saying, okay, well, turn the motor, the left side motor to -3 and the right side to -3. And here it's saying, okay, you have all the other motors have instructions too, and generally they're saying just hold your position, hold whatever body segment you're responsible for in its current angle. So they're just saying, the angle range is reached for the left foot because we want to hold that. Left leg Z. So moving forward, orange means that it's, according to the gyroscope, it's going in the correct direction to get to its target angle. So we can see 4 motors are thrusting. The ankle and side motors are thrusting. So we can just keep effing forward this. But one faster way to move forward is to press the period. That will take it to the next occurrence of the same accelerometer, like here at ETHXL's left leg. Or I think it will take you actually 10 milliseconds forward, right? So it's right leg, 47 milliseconds, right leg, 57 milliseconds, 67. So you can really skip forward 1 10 millisecond frame at a time, which 10 milliseconds is the accelerometer sample. So 100 times a second. So you're really skipping forward. You're really looking at a very small piece of time, 10 milliseconds. And you can see also that this is in fact real time. This is the RT preempt is enabled, so you can see that the time 77, each 10 milliseconds 87, they're exactly on to the millisecond at least. 107, again we're getting the right leg every time. 117 right leg accelerometer, 127, 137, 147. You can see that as we move forward, the gyroscope is picking up in the Z. Lower, the G represents gyroscope. On the lower left leg. This means that this robot and the lower left leg in particular are moving with a -5 Z, which is Z is forward and backwards, that axis. So it's moving, turning around that's going to be your roll. And so rolling to the left is a minus. So we can see that it is rolling to the left, basically. Picking up a little bit of speed, and we can just continue forward a little bit faster here. It looks like it's going to reach its target angle of -5, which is a pretty far angle. Maybe that's why it's maybe a little too far. Here, reach it. It's -5 plus or -1. So it turns green. It reached its destination, -4. Notice it still has a lot of motion, -9 degrees per second. That's something that could be a problem. Okay, so now it says stage 2, where we reach stage 2, where we want to pull this upper body weight over the left leg. Otherwise there's still a lot of weight on that right leg and it won't lift. You need to really remove the weight. You need to pull it with the torso a little bit. So what we want is this torso Z to be 0, not 2.49. So let's see, and it does look like it's going in the correct direction because it's orange, it's a minus, it's getting smaller, it's getting less, it's subtracting -2 degrees per second every 10 milliseconds. So it looks like it's doing it. And you can see that other motors are thrusting. The knee is thrusting because it looks like the left upper leg, which it's responsible for in this particular script, has fallen out of, it's supposed to be 6.93, but it's 8.19. So it's out of range, and that means that it's positive X it's falling backwards, basically. Positive X pitch is backwards, like the pilot's pulling back up, right, to pull the plane upwards, right? That's a positive X, that's a positive pitch. And that's what's happening. This robot's falling backwards. The torso is slightly. So, and you can see that if you look at the angle. So anyway, it looks like it's on its way. Oh, it looks like it fixed it, basically. So the knee motor fixed that problem, which is very nice. So but here now, unfortunately, the torso Z has fallen in the wrong direction. It's red, right? So it's not going in the correct direction. And now the X of the torso, but look, it went back, has got a problem. It's falling forward, right? So that has to be fixed. All this stuff's happening at the millisecond level. It was fixed, right, by the torso motor giving a little thrust. So we're moving in the right direction for the, but it just stopped. It's kind of oscillating a little bit. Now it's back in the right direction, right, orange, but again, the torso has fallen. It looks in a positive direction, fallen backwards a little bit. So it keeps sort of going on this way until we can reach a green, until we get to that angle where we really have the torso straightened out. It's pulling a little bit of weight off of that right leg. There it is, it's in green. We've reached the end of stage 2. It completed successfully. Now stage 3, lift the leg, this right leg. So we should see the right leg come up. And you can see the right leg is, let's see, starting to come up there a little bit. And it's a very short lift. We reach it. There it is, basically. That's as high up as I want to get it. Now stage 4, balance it. So now it's balancing, and you can see mostly it's the responsibility of the left leg to balance. And one problem, I've been working with this for a while, is that the ankle must hold this lower left leg all the weight to the left from the robot's perspective, and it has trouble doing it. It's a great weight above the ankle. So you can see, and here it's losing that battle. Here we see the lower leg Z. It's supposed to be -7. It's currently -2 and gaining, moving at 17 degrees per second to the right in terms of pitch. There's no way this ankle motor is thrusting at 12, very high thrust. It's going to be able to pull that back. The weight is pretty much, it's over, right? At this point, the robot's going to fall. So here you can see it's falling. There's nothing that can do, and it's aborted at that point. It says there's a message here. I'm not sure what it was. Oops. There's a little problem back framing on this, but you can see how that basic work goes. So then you go in there and you're like, all right, well, let's see, how can we push it, how can we fix that so that the ankle doesn't have so much trouble, if I get my neurons, holding that robot weight there. You know, that's pretty much how it goes.